Something just happened in deep space that scientists were not prepared to see. A black hole changed direction. And unlike most discoveries, this one didn't come with an explanation waiting behind it. No theory, no model, no clean answer. Just data that refused to behave. Black holes are supposed to be the most stable objects in the universe. They don't wander, they don't flinch. They sit at the center of galaxies like cosmic anchors, locking everything around them into predictable motion. That's why this event triggered immediate alarm. Because the moment astronomers realized the black hole had turned, they understood something else had to be true. Something else had interfered. The evidence came from a jet of energy stretching thousands of light years across space. For years it pointed in the same direction, acting like a fixed arrow. Then it didn't. The jet bent. Not slightly, not gradually, but clearly enough to rule out coincidence. Multiple observatories confirmed it. Different wavelengths, different instruments, same result. The source had shifted. That alone would be strange, but what followed was worse. The change didn't stop. Over time, the jet continued to drift, as if the black hole was still responding to a force no one could see. That's when scientists stopped asking how this happened and started asking what kind of universe allows it to happen at all. Because rotating a black hole of this size requires absurd amounts of energy. Not star-level energy, not supernova-level energy, something far more extreme. And nothing visible was nearby. No galaxy collision, no massive star cluster, no obvious culprit. Just a quiet region of space and a black hole behaving like it had been pushed. This is not a story about a malfunctioning telescope. It's about a system that behaved exactly as it should, except for one detail that breaks everything. This black hole didn't act alone, it reacted. And whatever triggered that reaction left almost no trace behind. That's what makes this discovery so disturbing. Because if black holes can respond to invisible influences, then the universe may be filled with forces we barely register. Forces strong enough to redirect the heaviest objects that exist. And if that's true, then stability itself may be an illusion. To understand why this is so unsettling, you need to understand what should have happened instead. When black holes change orientation, it usually takes millions of years. Slow interactions, gradual mergers, chaotic growth. But this wasn't slow. It was detectable within human observation timescales. That immediately ruled out most known mechanisms. Accretion disks can wobble, but they don't rotate an entire system this cleanly. Magnetic fields can twist jets, but they leave chaotic signatures. This shift was organized, coherent, purposeful. Astronomers then looked at the stars orbiting nearby. Their motion should have remained stable even if the jet changed. It didn't. Several stellar orbits showed signs of distortion, as if the gravitational center had been tugged sideways. That meant the black hole itself had responded, not just its surroundings. At this point, scientists considered the most extreme possibility, a close gravitational encounter. Something massive passed nearby and pulled on it. The obvious candidate was another black hole. But that explanation collapsed quickly. A black hole flyby would generate powerful gravitational waves. Those waves would echo across detectors. They didn't. The data showed something quieter, cleaner, almost surgical. Then came the discovery of a faint, linear disturbance crossing the region, a trail of energized matter aligned perfectly with the black hole's shift. Not debris, not gas clouds, a wake, as if something compact had passed through at enormous speed. This revived a long-ignored idea, rogue black holes, objects ejected from galaxies long ago, drifting invisibly through intergalactic space. Theoretically possible, rare, dangerous. A rogue black hole passing close enough could exert a brief but massive gravitational pull without staying long enough to leave obvious damage. That would fit the observations. But there was a problem. The inferred motion suggested acceleration. Whatever passed through wasn't slowing down, it was speeding up. Gravity doesn't work like that without sustained interaction. Which led to a more radical question. What if the black hole didn't encounter another object at all? What if it encountered a moving structure in spacetime itself? Something that carries gravitational influence without mass. Something that doesn't collide, but still pushes. The idea sounds impossible until you look at the timing. Alongside the directional change, detectors recorded subtle gravitational disturbances, not bursts, not crashes, pulses, repeating signals spaced with uncanny regularity. That alone is unusual. Gravity usually announces itself once, then fades, but this signal persisted. Worse, it showed internal structure, harmonics layered inside harmonics. That pattern doesn't match black hole mergers, it doesn't match neutron stars, it doesn't match anything in the standard catalog. But it does appear in theoretical models involving space-time defects, structures predicted by some advanced theories where space itself can form stable distortions. Think of them not as objects, but as features, wrinkles, knots, moving regions where space-time behaves differently. If such a feature passed near a black hole, the interaction would be dramatic but brief. The black hole wouldn't absorb it, it couldn't. Instead, it would reorient in response, like a gyroscope nudged by an invisible hand. This would also explain the pulses. The disturbance would continue traveling, leaving a trail of gravitational ripples behind it. When astronomers mapped the direction of those ripples, they converged on an unexpected destination. A massive cosmic void, a region of space believed to contain almost nothing. But new lensing data revealed something hiding there. Light bending, distortion without visible matter, a gravitational presence without a source. That discovery changed the interpretation entirely. The black hole didn't turn randomly. It may have reacted to a much larger structure embedded in the universe's framework, one we've been flying past for billions of years without noticing. If that's true, then black holes are not just endpoints of gravity. They are indicators, responding to deep-scale distortions in the universe itself. This doesn't mean physics has failed. It means our map is incomplete. And this black hole may be the first signpost pointing toward what's missing. What makes this discovery so powerful is not certainty, but vulnerability. For once, scientists can't close the case. The data is solid. The interpretation is open. And that gap is where progress happens. If invisible gravitational structures exist, they could influence galaxy evolution, black hole alignment, and cosmic architecture on scales we've never modeled. They could explain anomalies we've ignored for decades, subtle lensing, unexplained motions, background noise dismissed as error. Suddenly, those loose ends connect. This also reframes how we think about black holes themselves. They may not be the ultimate rulers of their environments. They may be responders, reacting to deeper currents flowing through spacetime. That idea is unsettling, but also elegant. It suggests the universe has layers of structure we're only beginning to sense. Right now, astronomers are watching closely. The jet continues to evolve. The pulses continue to arrive. Whatever caused this has not finished passing through, and that means future shifts are possible. Not dramatic catastrophes, but quiet signals, slight bends, subtle changes, clues hidden in plain sight. The universe rarely announces its secrets loudly. It whispers. This black hole didn't roar, it turned. And that small motion may end up telling us more about reality than the most violent explosions ever recorded. Because when the most stable objects in existence start reacting to unseen forces, it means the universe is far more dynamic and far less understood than we ever assumed.